Good morning. Hello. Happy Monday. Let's see. Today we are going to be working on, well, I guess like we're continuing to work on the tutorial, but I think now we got to go back into ECS and like prepare it proper for what we want to do. So my thought process on this entire thing is this is like writing this forces the coder to like sort of dive a little bit deeper into like Rust stuff. It's like we need RC and RefCell. In order to use RC and RefCell, you have to understand it a bit, and amongst other things like that. So that's what like this tutorial is all going to be about. Is like basically, hey, let's have an excuse to like play around with those type of things. So if we look inside of ECS, let's see, why isn't he? We're probably gonna put a bunch of stuff in here for like the actual tutorial itself, along with maybe like links to the videos and like the what to do. This is fine. So let's start with our world. Yeah, there's gonna be a lot about dynamic dispatch as well. Okay, so drive, debug, and default. So the first step is basically we're creating the world, and then we're gonna want test cases for like how this entire thing works. So something I've never really thought about is like, do we put comments above or below this? I think above this. So the world is the main sort of like exported object, or like entry is the main. From this world, you can only gain access to like resources and entities. So these are one-off pieces of data. Okay, so the resources are basically things, these one-off things. Like an example of a resource, the player's name, like the location that the mouse was clicked, the FPS. The FPS. The entities are a collection of components. Components stored. I guess I should probably like talk about that separately. So like the entities are the objects that they don't own the resources. I think I have to like turn you off temporarily. Just temporarily. Okay. The entities are the objects that let's see. Entities in this case, they're like are the objects like in the game world. Examples of entities would be like the main player. Enemies. Background. Sprites. And any cameras. Entities. Okay, so entities are almost always made up of multiple components, or discrete pieces of data. I think like something that's kind of important here is by deriving debug at this point, we then force resources and entities to derive debug. And then when we tell them that they have to derive debug, suddenly everything else needs to start deriving debug too. So we could also start coming up with like a list of the videos for this, like the tutorials. So let's see, build improve Rust skills by making ECS. It's basically like the video tutorials. Okay, so what do we want? I mean, obviously besides like introduction, for example, but this is going to be things like deriving debug. Deriving debug forces everything to derive debug. Let's see. So like something else to like look into, cargo expand. So cargo expand to see what a macro is expanding to. So a lot of these are sort of like forwarding. Like there's hardly anything that's happening here. but because we don't really want people to go directly into resources or entities, we're taking in the methods here and then just forwarding them onto whatever they are. And then that's kind of it for this thing. Now in here, do have like this one be pub, and I think I did this one so I can just look inside of entities from something else just to see like, hey, what's going on here? This doesn't actually have to be public. I could remain like keep this like that. I think we'll be fine. This is a super interesting pattern here. So create a new world, a new empty world, default world. Since we are deriving default for a world, we don't need to then we don't really like, then we could just use. Then we can use the default So then the doc tests are also like something interesting. It's like this could be a good example of like how to do a basic, just like really basic doc test. So let's see. I don't think we need to pull anything in for this type of thing. I'd be curious. So if I do let equals I don't think there's anything there. If I run this, couldn't compile. Oh, not found in scope. Okay, so we have to. Oh, consider importing this struct. So then we have to do use then we can do this. Yeah, there we go. Okay, that works. Okay, so basically writing documentation and doc tests. So specifically for this, pulling in the create, like using these statements, access to the code. Lord Mizd, hello. How are you doing today? Oh, great. That is awesome to hear. So add resource. Okay, so we want to, so I guess like in here we'll also need like what is ECS why would a game developer want to use one? Suppose there's like the introduction, why build our own ECS. Okay, so we want to store a resource into the world. We are using dynamic dispatch, allows us to take any type so like anything that has the provided trait. So in this case, this provided trait is the any trait. So here it's almost anything. Any is automatically added to a lot of things, right? I'm really curious about that. So if I let's open you up. I do cargo doc. Oh, I have to build all the docs for everything. I forgot. It's not just this one, but everything. Guess that makes. Oh, I had already built most of the docs. Oh, documentation and doc tests. Okay. And like things I want to make sure that we hit is doc. Okay, you opened over here. Oh, wrong one. There we go. Okay, so here's all this stuff that we added in here. So if we go into the world, then we can see well, interesting. By deriving debug for this, did I just like? Oh, I just forgot. I just didn't like finish writing this statement. That's interesting. By deriving debug for this, are forcing the user of the library to derive or implement debug for all of their resources and debug for all their resources and whatever it's called. Ooh, let's see. Resources and components. This isn't necessarily a bad thing, but is something to be aware of. And that's where like the cargo expand to sort of like show what that is, and we have that there. Okay, so we have that. So, okay, if I come back to here and I just recompile this, and there we go. Okay, so this is all added in here. Implementations. Okay, so we have this impl world, we have new create a new. Okay, and then this shows that and working. So awesome. Almost anything. So I'm actually curious. World. There's something here that shows the traits, right? Trait implementations. Auto trait implementations. I don't see. Oh no, here it is. Blanket implementations. Any. So we can see any here is added in for world, even though I didn't like add it in myself. I think the thing that I'm thinking about for like the minimal is it's sort of like a canary test, meaning that like if you can't get that to work, then like there's something seriously wrong. For me, the thing that like in order to even do this, you have to do this in here. So a lot of like what I'm writing in here isn't like necessarily helpful for a from a like true documentation way, but I'm trying to go from like more of an educational slant of like what it is doing, even though like why you're doing it is actually like the real reason why you want to do the documentation. But yeah, like I think like a lot of people might run into trouble saying like, hey, look, world. You need to pull in world. Why doesn't it work? Why do you have to do this? Anyways, that was my thought about it. I think that shouldn't go in doc test. Doc test should be helpful for people reading the docs. Yeah, I can see that too. Like we could also skip that and not do that here. And like we'll have to figure out some other system for this of where to put it. Let's see, any trait, let's pass in almost anything. Okay, so then here we'll have dynamic dispatch. So then no. So then part of dynamic dispatch there is using the any trait and then like using custom traits. Well, yeah, I wouldn't expect a user to do that, but I guess like how low level or how low level, what sort of like skills of a person am I expecting the user of this tutorial to be? I don't know. My thought is it might be somebody who is like also thinking of going through the book, or trying to go through the book at the same time, or maybe forgot. But we could also find, I'd assume the skills that you get from the Rust book. Yeah, I met some people recently who were like, they read through the Rust book and then they're like, I didn't really get it, or I had trouble understanding it. So, but I think you're right. We're gonna have doc tests somewhere else, and that will force us to use it there. So it'll still be there. We don't have to add it in at this point in time. Okay, so anything new? All right, so then the new thing here is like we have generics. Oh, generics. So we have generics. Sort of like, what are generics? I guess like that's gonna be an entire generics. What are generics in Rust? A bit, let's see, for I think it's fine if you're not teaching Rust, but only showing how to use the library. Yeah, and I think that's like a big difference is a lot of what I'm writing here isn't necessarily what I would write for like if this is a real library that like I'm expecting people to use for real, like developers, because this isn't really explaining the whys. This is explaining the hows. Okay, so what are generics in Rust? How to limit how to restrict the created code, code to handle the generic types. So out of curiosity, can I use cargo expand with generics? Yeah, restrict the types. Restrict the types might be good. Restrict the types. Restrict the types to there, just like that. Okay. Is there something like cargo expand for generics? That would be really nice. Or does the playground, can that let me do stuff? Oh, I can't do like line here. It's trying to use like VS Code. No, oh man, okay. So if I have like a function test, taking a T, and you are, let's say a, I don't know, what was it? You're an any plus static. You take in like something, which is a T. Oh, we should also, in this specific case, we'll do debug. Then we'll call this logit. And this can just debug logit. So if I do that, I can now call logit. So logit and pass in like 55. So if I do that and run, this should just work. Oh, I need to pull in any, don't I? I keep on forgetting that, like, it's just so easy to like pull in these things. Use standard ops any. It's not ops. No, it's not ops. It's something. Oh, standard any. That makes sense. Standard any. Oh, and I probably need to pull in debug too, don't I? I do. And you, okay, so let's see. Debug standard. We can let's try that. Let's see. Standard. Where is debug? There's debug macro. Derive macro. So that's the, okay, this is the trait. Standard format debug. Interesting. There's the debug macro is in here too. So use standard format debug also. Run cargo reci, emit LLVM IR, and then read the IR. It should give you some more infos than the generics, I hope. Well, let's find out. Oh, I don't want to debug something. Okay, so that's a way to do that. Now, if I take you, can I tell this to compile it in that way? And then I can tell you to run. So what is it? LVM IR. If you have the debug trait bound, you don't need any. Well, maybe you will for some other things, but you shouldn't use it here. I thought I would need it here to use the debug thing there. Yeah, so if I don't have this, I would assume that it should yell at me. Yeah. T cannot be formatted using debug because it doesn't implement debug. So in this case, because I'm doing this, I have to do the debug like that. Oh, you remove the any bound. That's true. I wonder if I could just do that. Okay, where's my output? 55, okay. So here's this. So is this all the different types? It's like load all this value, like start, allocate. How far do I need to go? Oh, I can't like make this bigger. I don't know where to stop scrolling. Just for logit. Okay, can I do that? Okay, so here it is. Playground main. So here call playground, that's about halfway through. Call void to that. Now, can I see? Okay, so call it into it with an I32 55. Okay, so that makes sense there. I32 something. I32, I64. I8, I32. Well, the type is an I32. It's like something behind the scenes is that when we use the generics, it's creating like another function. It's creating multiple functions for like each type, right? So I'm guessing that like here we can allocate an I8 and I32. Strings also work though, right? Or would that only put like in as still I8s and I32s? It's like I64, I8. Yeah, that's a good question. So there's 8 matches here. Okay, so this is I32. So that makes a very specific I32. Now, if I do like IF32, okay, so then here we see float. So I8, I32, I64, I8, I float. That define internal thing is what's interesting here. Yeah, so float something. Personality, I32. I32, I64. Yeah, as the parameters including this, like float something. So that's like float my thing. Okay, so something could be interesting here. Like what if I were to do this twice, right? So if I do log it with 55 and then log it with like a string. Let's do like an actual string. I don't see the string. Oh, I don't see the hello. $16 matches now. Okay, so call into void, or sorry, call into float, and then a call into string. But define internal, log it. So string. So yeah, every time we have like this define, and then float. Distinct, log it, allocate string. So it only defined 2 times. I could swear that the book says that internally. Maybe I'm just wrong about this. Rust. Ugafa, hello, good morning. So does it not say that? Did somebody tell me that and then I just sort of like ran with it and I'm just been wrong this entire time, which is very possible. So it only created what I absolutely needed to. Let's see, I did mention there's another time that used this. I guess I must be wrong. Or maybe I have old information and it's no longer like this. Either way, I am happy to know the right way. So generics, what are generics in Rust? There might be something completely different in the assembly. Yes, that's... So if I search for logit, okay, so string it looks like it's just using that same function, which makes a lot of sense, right? Because assembly doesn't care about types. That's just at our very higher level language. We care about types. So it's just the various calls to logit here. It's defining it and then calling it. So it's like before assembly. Yeah, I'm not very good like at reading assembly either. I've never really needed to for like debugging or like doing my own code, but I haven't done like enough in like C or C++ to like get to that point. So like our biggest things in generics here that we see is it creates just enough functions to handle the different types that we need. So if we have like if we're using generics and we're going to pass in like 4 different data types into this generic function, it'll create 4 different functions in the source, like in the LLVM, before it then goes off to assembly, which then is back to 1 source code, which is super fascinating that it does that. Let's see. In LLVM, IR, then back to only 1. That sounds inaccurate. Probably inaccurate. LVM is completely unpredictable. If it is unpredictable, then I should probably just not talk about it. Is LLVM, so like I don't know much about LLVM besides like it just does all the cool stuff for us behind the scenes. But I hear a lot of people complaining about it a lot. So there is that. So Rust codes, because Rust C, and then LVM IR, Blackmagic, ASM, assembler, binary. So what are generics in Rust as far as we are concerned at a high level? Selective duplicate. We're creating our list of like videos and courses and like preparing BBECS for tutorial time. So that's what we're doing here. And then doing any research we need as for like understanding what it is that we're doing. Like specifically for this. So this is the first instance of generics that we have in here. Also, we have options. So this is like options. Okay, so in here, resource function takes in a generic type. Generic type. In order to tell the compiler do as much information about what kind of type to expect. We are constraining the incoming types with the syntax. In this case, our generic type doesn't have anything to do with what we are passing into the function, but rather what is going to be returned. We are telling the compiler to handle any type that implements the any and static traits. You think it's pretty strange that you don't have something like a component trait? Yeah, we could do that. I was trying to use like the any trait because I saw some of the other ECS libraries doing that, specifically like hex. Which I kind of liked, and also like I think any trait could like be really interesting to somebody else who knows, like at least it sort of like feels like, oh man, I can use anything. It's like, yeah, but be careful about that, because then you have to downcast. So that means in here we're gonna want any traits. We also have like the static trait, which like the static trait really is just about at compile time, we know how much space it takes in memory. To be honest, this doesn't seem like you're teaching beginners good practices. I mean, in ECS it might make sense, but it's something you usually shouldn't do. I guess it's a bit like showing a beginner to throw RCs at the borrow checker. That's a good point. So maybe I shouldn't aim at beginners then for this one, and we can do another thing for beginners later. That is a good point. Or I could hold off on creating the videos for this one, do a beginner one, so I can prepare this, do a beginner one, and then come back and do this. Yeah, that could work also. Or we can rewrite this to not use, no, because like ECS, it's like this one, maybe we should like do, instead of like level up our, like improve our Rust skills, like as opposed to learn Rust. It's like we could do something else of like learn Rust by building something completely different, probably not have any generics in it at all then. And I can see us deciding to do like just, okay, here's how to do this project, which is gonna force you to go deeper into these Rusts and implement these things, or at least understand how they, like, that they exist and work. So I did that the first time. The first time through BBECS, I used an enum variant for this. The problem for the enum variant is that it takes up like space in memory for the largest potential arm of that variant, which then got pretty big. So the it seems like, I guess like another way is like, instead of using an enum, would be to essentially create our own enum using the struct that could then choose between one of the different things. That way it's not like taking up all the space. Oh, the user supplies the enum. Oh yeah, that could work too. So a user supplies the enum. So then it would be just a single type, a single component type. That could be interesting, yeah. I think a big enum is still way better than storing everything on the heap. And if the user thinks a variant of the enum is too big, there's nothing stopping them from using a box for that variant and putting it on the heap. Yeah, that's true. I'm trying to think also if well, because like we could abandon BBECS and just say like, okay, we just like did this for like our learning, like, you know, you watched the videos, you're fine here. We could pivot over to basically like a to-do list, something like that. That would be a lot easier and simpler to build for like a tutorial series of like, here, actual like Rust code, high quality, like what you're actually supposed to be doing. We could still come back to something like this later once we get to the point where it's more advanced. I guess like I'm trying to figure out how much of this do I need to change to handle something. Because let's see, if we go back to the playground here. So if I do function main, let's do like our struct world, and I want to take in a world. So pub function, let's do like add resource. Now, are you talking about not using generics at all? I think you're talking about not using dynamic dispatch, right? I suppose like if I have we'd have to have something like a trait resource. We don't have anything in there. Then impl, then we'd have like an enum for like my resources. So in here we might have something like FPS, which is like an F30. I guess that's more of like a U32. We have, I think it was like a F64, I think. Then we have a, maybe like a location. It's like quick location. That's going to be, let's say like an F32. Then we would need to impl resource for my resources. Okay, we don't really need to do much for this, but this allows me to then, okay, so in here we have this add resource. We want to take in this type that implements resource. Then we're going to take in the resource, which is this T, and I don't want to return anything as part of this. Wait, resource T. Then let's just, I guess, like debug out. So you're going to need to debug out the resource handed in. So then you need to derive debug, send in main. We're gonna do that world. Oh, add resource. Self. Set new world equals world like that. We can do world dot add resource, and in this case, we're going to hand it a my resources FPS. Let's say FPS of like 97.8. So if I run this, not a trait. Isn't debug a trait? Drive debug. Drive debug. Did I do this wrong? I have to pull in debug there. Oh, right. It's, no, I don't have drive. Okay. Expected trait, found the drive. Oh, wait. That's not the problem. Problem is here. This is standard T, like that. So that gives us that. So if we want more complicated stuff here, then it ends up being like inside of the tuples where you store the stuff. You can make this nicer by making a derive macro that derives a custom trait on the enum. What would that do for us here? Because in this case, like if I wanted a more so this, I don't think this assumes that every variant is only has one field, because like let's say we like this click location is basically really simple like this. So normally we do something like we'd have like a struct location, and that's gonna have like an X F32, a Y F32. And so in here we would say you are a location. This should still work. Oh, struct location is gonna have to drive debug. And that still works here. So we could create a location if we wanted to. So we can do world.add resource. It's gonna be my resources. My location? Click location. And then a location with the X being like, 100.0 and the Y being 50.0. It's like this should also work. Where we see those both come down here. So like the big thing about ECS here is the so like advanced memory management to minimize cache misses. Lumacode, hello. Then the separation of concerns. I mean, yes. I think like I think the other thing that like ECS does for us, and like yes, it's like separation of concerns here, but like forces a data-oriented design and programming style. So it's great if you want to sort of like learn that. I guess also the other thing that we can mention in here is part of our introduction to this project. We're basing the ECS library on hex. Okay, so then here, anything new here that's going on? Resource mute? Not really. This is like exactly the same thing, but like get mutable, get not mutable are like two different things. So because we are storing the resources as they are, just like normally, then we have the option of getting them immutably or mutably. It's I guess like it is a good idea to like have the options for both instead of trying to do like only one or the other. Give the ability to get mutably and immutably separately. I don't actually know if I need register entity. Am I using this? It's like if I search for register entity in all of Zombie Simulator. Let's see, is there a search? Register entity. Oh, I am. Okay. Oh yeah, I am. In the main library and then in add zombie. Okay. I was thinking about a different thing for this. Okay, so for register entities, this is like beginning of the builder pattern because like we're turning a mutable reference to an entity. So you know, I wonder if like this is gonna be less of like a tutorial on like builder pattern and more of we're just gonna do micro videos on like each of these different things. And then they don't have to be part of this specific project. We can do micro little projects for each of them. That actually might be a better idea. I kind of like that more. Okay, so then, like, we have patterns. That's design patterns? Programming patterns? So in this case, we have a builder pattern. So we're using the builder pattern here. Allows a user to create an entity all in one go. In one go using dot syntax. So this might benefit from an example here. So what I mean from this, we need to use world so to grab this out, okay, so we need a new world. So we create a new world for this, and then I want to register an entity. So we're going to be able to do world.register entity. So then this returns a mutable reference to the entities struct, which will allow us to add all of the components for this entity. Okay, so then we're going to do dot with component, and then we have to like hand it what this component is going to be. So if I do something like 15.0 F32, assumes that only F32, only one F32 component exists in the entire world, but is like does work. Okay, so with component 15.0 F32, this assumes only one F32 component exists in the entire world. Then we can do it again. So with component, and maybe we have something like 42. I32. We can chain adding the components together for this entity, since I guess dot notation is a big part of this too. Don't know where to put that. So like what? Like let's see. Call a function and then dot to call something on the function's return value. Okay, that's correct. Then there's like also a big thing about dot notation is like dot something will auto dereference whatever it is attached to. Okay, so with component there, and then we have that. Okay, so that works there. Now this should work. It should, okay, it doesn't work. What doesn't work? Okay, semicolon. Missed the semicolon. Okay, so then that's that. This query is like essentially the same thing. So like, there's nothing new that we haven't talked about up here after this. Should probably talk about that stuff up there too. Let's see, remove component. So type of is a new thing. So since we are storing the components in a hash map, so that's gonna be in here too. I guess like the data structures. Hash map. Since we are storing the components in a hash map, using the type ID as the key, we need to get that type ID. We want to find that component, that list of components again, and get the type ID off of any generic using type ID in the type ID struct. Otherwise we can call dot type ID on any like actual concrete type. I guess it's not really like a concrete type, right? Like just on like something that we have. On an instance, like on actual things. on something. I don't know what to call it. Like on a variable? On data? So in here, getting that. So I also don't know where to throw this. I just like, I guess we could have like a types. Then in here, we'd have like a type ID, how to deal with that. Also, something else we haven't really talked about here is the self. So the self tells this tells the compiler that this method is, or that this function is a method available to instantiated sort of like objects in quotes, objects of the parent struct. Only way this can be called is by first creating instance of the world. So so we have use ECS world let you, I guess in this case it's let world equals new, and then query equals world dot query. So that works. This, however, would not. So we cannot do world dot query this won't work because dot syntax, because we can only call functions on instantiated objects. It's not really an object though. Instantiated things, instantiated items from like from a struct. But it's not like not completely true either, because like not everything is from a struct. So we can only call query after it's been instantiated. This is because the query has a self defined in the method signature. So that's world.query here. The other way to do it, potentially, would be world query, like that. This also won't work because the method query has the self parameter argument. No, it's argument. No, it's parameter. Parameter as a self parameter tells the compiler that it is a method on available or instantiated instances of world. Now the compiler will be nice and tell you, hey, you can't do this, but there is a method that you probably can. So this should still work here because these are all comments. So if I were to rerun doc, here's all of this. Add component to entity. Let's see. I don't see anything else that's like super special. This is just really like forwarding on like what's happening inside. So in this case, what's gonna, like, just in general, what happens here, we'll add any component to an entity, to an existing entity, even if the component type hasn't been seen before. Entity index is the index of the what is it called? It's the index of the full is the index of the entity in the components tables. There's components vectors. Let's see. Other things in here. There was some like types of like usize, and it's like that might be interesting. It's like number types, like size versus like U32 versus like U8 and so on. Okay, so use statements. So these are like equivalents of an import / require. What's the other? I don't know. Like from other languages. This allows us to reference the imported thing directly instead of having to get its full path in the code directly. So an example of that would be like any instead of standard any. Example, and use any instead of standard any. Okay, so there's that. And also bring in local. Bring in local modules, as well as any system or external crates using this same syntax. Is this gonna yell at us? So far not, okay. Okay, so then up here we have, let's see, this is defining, so, module system, so like, make, like, tell, okay, this is tell, Rust that, following modules are available. I think these actually need to be just normal comments, don't they? And if I do that, are you gonna allow me to go back up there? No? Okay, so you can stay that way. Let's see. Okay, so tell rest of the following modules are available, and we want to access code in them. So in our case here, we're just going for files. So in this case, look for files named entities all errors and so on. However, we could also define a folder named entities and put a mod.rs file inside it, and this syntax would still work. It's like the module system I know is confusing to a lot of people. Because like there's essentially 3 different ways to do it. Also something else that's probably really important here. By making these public, we are essentially exporting them to the users of this library. It's not like good nor bad, it's just a thing. So I'm curious, if I do add in these and I compile, I don't think these get seen. Let's see, there's the re-exported methods, blanket invitations, modules. Okay, so here's for the modules. Yeah, but they're not visible here. If we go inside, oh, interesting. So this now is then inside of, okay, entities here. That's interesting. So that's all of this. So let's go into our do errors next. Okay, so partial equal to. So that's something that allows us to like comparisons. So specifically with like data structures, if we have something like an enum, but then inside of that, we want to compare together, like we have a couple different choices, right? We can use matches, or we can use the, what is it called? The partial equal derived macro. Okay, so list of errors that we can like return as part of the results. Are using the external create this error allows us to like set up this error enum very easily out a lot of boilerplate. So specifically, when the error is printed out to the screen, if error was component not found, then the string component for entity not found is what would print out before the stack trace. Which is actually really nice. This error can do a lot more, including taking variables and so error handling, it's like the big thing. I see someone using comments to explain why they're doing something a certain way. Well, I'm like the main one is like not. This is more of like a lot of what's also. So it's like not exactly right for that, but I figure like it's in a lot like this case it's more of like a teaching tool for like, hey, here's this thing that we're doing, this is what's actually happening. So the what also helps too. Lord Mist, okay, so you got a super fancy way you can do an ECS library that is really convenient to use and uses derive macros. You've written down what they generate manually. Okay, let's take a look at this. Okay, so you have your hash map new, resource insert. Okay, so you like my resource kind. Did you create my resource kind? You did. Okay, so like, okay, so this would be generated by the derive macro. Interesting. So you'd create a bunch of these enums? Cat Jam. I don't. Yeah, Zilby's not down here right now. I would love to like have him hang out with me, but nope. I think he's upstairs begging for food. Okay, so let's see. Reese's. Okay, so the insert. So stir. Okay, so you have basically my resource kind is an enum, but you're saying my resource kind is going to be automatically generated, and so that's going to be position and string. String from, I'm a string component. Okay, yeah, that makes sense. That entity equals entity resources. Okay, so entity resources hash map, my kind. The macro could generate a trait implementation on my resource, which defines gets the kind, like so like various gets and that kind of stuff. Okay, so then we have this equal entity try get resource. Okay. Now for your entity. So you have my resource. Okay, so your entities are actually made of resources and not components. Within, let's see. It's a struct, right? It's still... Resource is a hash map. Okay, so you have a string of those. Okay, so you have a lot of hash maps then. It's like each entity is made up of many resources. Wait, so if I wanted to like make 1,000 of these, or 500 of them, would it then be over 500? I guess it'd be 500 hash maps. Each entity has a map of resources. Hash maps aren't going to be stored next to each other in memory, right? That's going to be the main issue here. Because hash maps are not stored next to each other in memory, with the system, yeah, I think we're going to get a lot of cache misses with this. No, this is just a jacket. This is not PJs. I'm not in PJs. Also, good morning, stacking. Also, it is 8:40. That is correct. I do need to go get ready for work very soon. Okay, so I think let's see, would it be considered? I don't know if it would be considered an ECS system. I wonder. ECS characteristics. It's like an entity. I guess this would work because it's structs of entity. So technically it still would be a thing. So like that would work technically. Wait, we're over here. So yeah, it's still a ECS then. It still falls under the definition of it. Let's see. It's different than the one I've done. Because what I'm doing is like just the array or like the list of components that are sort of like separated from each other, and these ones are like together named in the entity. So let's see. This might be interesting to try to build something with, like this pattern. So how do I... Was this a permalink that you gave me? I want to make sure that I keep it. So... alternate architectures consider. So this is a lowered midst. All right, so I want to keep that and not lose it. When this is done, you'd really just have to declare an entity, a resource enum, slap derives on them, and call entity add resource, my resource XX, and get entity add resource, and it figures out the type. Your example shows how that's possible. Yeah, it's I wonder if that would be better for like, if that is better for like game development, or if the more traditional ECS is better for game development. I don't know. The way Year does actually feels a lot closer to game development design patterns. The book, how that has it, which is like each entity is really a struct that has essentially links, like references to, like, I guess not references, but like what all the other discrete things are. So that could be good too. Although when I pull up like all the locations, I don't think I can in yours, right? I don't think I can pull up. Like, let's say I want all the locations and all the velocities together. I'm gonna get these entities, right? So if I want to get all the locations, I also get all this, right? Yeah, to be fair with your example, you might as well just use fields and instruct. You kind of are just using fields and instruct, right? Like I would argue that you are using fields and instruct. That was, I think, the cat upstairs freaking out. I'm probably gonna have to go check on him. But of course, it's almost like you're creating your own struct. That's actually pretty cool. I like that. Using the hash map to sort of like create the same thing as the struct. So there is a subtle difference for like the reason why, and I think that will be really good for us to go over, which is in the system that I'm doing. Instead of having this components map, you can have a field for components. It actually is a neat idea. I like that a lot. And there might be like a good reason to like go over and like actually just explore that really deeply. And like, here's a struct, let's create this. That'll be cool. And then maybe like do something with it. What the ECS that I'm building, or that I've done, and like what Hex and Specs and Bevy ECS does behind the scenes is this style. So you have a vector or array essentially of all the different locations down, and essentially you're making an entire database in memory that have nothing to do with each other. This website, it's Envision's Freehand. It's my favorite whiteboarding app. I have requested that they give us sort of like a dark mode for it. They haven't put it on the roadmap yet. They're researching the idea. They add it to their feature requests. But yeah, like then we can use structs inside of here, which would be pretty cool. So anyways, it is 8:45. Silly whiteboards. We all know blackboards are better. I know. The only negative about blackboards is the chalk, the chalk dust. Unless, of course, you don't have that problem because you're using like a black whiteboard, which like they sell. Like I found this out. There's whiteboard markers that are made for black backgrounds. Pretty cool. I've never seen one, so I've just heard that they exist. Anyways, everybody, it is 8:50. I was gonna say 8:90, but that's not right. I need to run really quickly, so I have to do an emergency stream shutdown thank you so much, Lord Mist, for the suggestions. That was pretty awesome. I like to see like where that's going and all the different options. I think for the ECS itself, I'm gonna stay with the traditional ECS because that's what everybody else is doing, or that's what all the other ECS systems are doing. But I really like that, so I'm gonna keep that around and like use that in something else, I think. So with that, everyone, I hope that you have a great day. I'll be back tomorrow morning at 7 a.m. Mountain Time to continue sort of like going through this, figuring out what we're going to do and how we're going to like build the tutorial system. Anyways, with that, have a great day and I'll see you next time. Bye.